Okay, well, let's dive right in to what's possible in 3DEXPERIENCE structural simulations. I'm talking about finite element analysis today, the questions of will it break, will it survive, is it going to overheat, and in a way, of course, that is connected to SOLIDWORKS. This is all possible because of this 3DEXPERIENCE platform, something from Dassault Systems, who owns SOLIDWORKS and quite a lot of other software. So I apologize, today I'm going to show some wordy slides. I really want to dissect the different brands and softwares that are available and the licensing that comes in between them, because Dassault Systems really is a juggernaut in the simulation space. They own all sorts of simulation softwares, from SOLIDWORKS simulation to CATIA analysis to Abacus, probably the most powerful nonlinear solver that's on the market, all the way up to fluid dynamics programs like XFlow and electromagnetics programs. But until just a couple years ago, these have always been separate individual entities, meaning what if you had a SOLIDWORKS design that you needed to do some really high-level analysis on? Well, you might save your file as a step file and then go open it up in this other software. So if you have to do an iteration, you're pretty much starting from scratch. Make your design change, save as a new step file. There's no way to do any design of experiments or parametric optimization this way. It's just not the way that SOLIDWORKS users want to work. We want all of our designs to be connected. That's the big advantage of the 3DEXPERIENCE platform for simulation users. We can now either install an add-in to SOLIDWORKS, where we simply save our files into 3DEXPERIENCE, or if you're new to SOLIDWORKS, you can start with 3DEXPERIENCE SOLIDWORKS. That's one that you can log into with just a email address and is already cloud connected for data management. Of course, all SOLIDWORKS installs locally, and big simulation softwares, they're also going to install locally, but we need some data translation in between. And since 3DEXPERIENCE provides us cloud data management, it does that transaction for us. We can simply save our files into it, open them up in another piece of software, yet we're still parametrically connected. We can make a change in SOLIDWORKS, rerun our simulation with that design change. We could do design of experiments iterations or optimizations this way, iteratively improving designs, staying connected the way you expect in SOLIDWORKS, even though we're in two different simulation packages. Now, if you're interested on just how that saving into the cloud works, definitely check out our YouTube videos on cloud data management. A lot of folks, that's a primary reason to look at 3DEXPERIENCE. Hey, we just want a cloud server. We don't have to set up and understand CAD references. And that's just scratching the surface. So definitely check that out. But I'm going to stick with simulation. Maybe I should go back to what we already have inside of SOLIDWORKS a little bit, which is 3 levels. When we look at licensing, you might talk SOLIDWORKS Simulation Standard, Professional, and Premium. And these all run inside SOLIDWORKS and really are tools that anyone who's using SOLIDWORKS, any designer, any engineer, can get a lot of use out of day one. That's the purpose of these. Use them as a design tool. You know, have stuff that is going to converge. We don't have any divergent analysis, stuff that you're going to get results from extremely fast. But sometimes you have to go higher than this. So first, if you're a SOLIDWORKS simulation user right now, let's say you're a SOLIDWORKS Simulation Premium user, and you're looking to go to a higher level, the next ones have these 2 titles. Structural Professional Engineer gives you the nonlinear solver of Abacus. And this is in the 3DEXPERIENCE side, so a little new interface. And then Structural Mechanics Engineer gives you the explicit dynamics solver of Abacus. So if you're a SOLIDWORKS Sim user now, these are the 2 I would look at next. In fact, I'll give you an example of why you would go here. Let's look at the workflow a little bit. This is from the perspective of an existing SOLIDWORKS, let's say, Simulation Premium user. So I'm inside of SOLIDWORKS and I have a part that I'm going to run a nonlinear analysis on. Something that is made out of rubber, let's say, has a nonlinear material. I'm going to be compressing quite a bit, so a lot of strain in the material, a lot of nonlinear contact. Well, you can run this in SOLIDWORKS Simulation Premium, but you might find that it stops at 60% and doesn't solve to 100%. This would really only happen in Simulation Premium nonlinear studies, and you do get iterative results, but it's one of the reasons that when it comes to Sim Premium, we're always working directly with our customers to make sure you're getting exactly the right tool for the job. And in the past, this would be the point maybe you would save out the step file and go to some other package. Well, now there is a connector, an add-in, right inside of SOLIDWORKS we can use to connect to 3DEXPERIENCE and simply open that same file up there. Now there is a new interface, but it's not all that different. I'll give you a closer look at it a little bit later on. But essentially everything that can be transferred, your geometry, your boundary conditions, your loads, will be transferred over. And then you can make whatever tweaks with the more powerful tools that you want to add. Maybe more accurate contact information, more accurate material information, and you're going to find it converges to 100%. You're now running the Abacus nonlinear solver. The big deal, though, to me, is you come back to SOLIDWORKS and say, oh, we need to make a design change. Based on what we learned there, maybe we're connected to do some optimization, or we just need to remove some material. That design updates automatically through the 3DEXPERIENCE Cloud Data Management. So you open it up again, and we just hit update. The geometry changes are there, and you can rerun the simulation. That's a parametric workflow. That's the whole goal of using these higher level simulation products with SOLIDWORKS. So I'm giving you this example from the perspective of a SOLIDWORKS sim user already. So let me go back and start there. In case you're not into SOLIDWORKS sim already, what's possible inside of SOLIDWORKS? Those ones that I said are for every designer, every SOLIDWORKS user that you can get value from right out the gate. They're easy to use, and there's tutorial built in, and MLC, of course, provides training, in-person live training to make you an expert at these tools. Now, the first level would be Simulation Standard, and it comes mainly with linear static FEA for parts and assemblies. Now, in fact, if you own SOLIDWORKS Premium, doesn't have simulation in the title, but it's just the 3D CAD SOLIDWORKS Premium, you actually do have linear static analysis for parts and assemblies. They throw that in. But SOLIDWORKS Simulation Standard will add fatigue studies and motion analysis to it. Now, I would say 90% of the SOLIDWORKS simulation users end up in the SOLIDWORKS Simulation Professional package. This builds on top of Standard, so it's got everything that has, and then you get a dozen other study types, maybe frequency, buckling, drop test, thermal, transient thermal, optimization and topology optimization, drop test, and we're still looking at stuff that is convergent, is going to solve to 100% every time, is very fast to get results out of. So it's just really good for anyone doing design. At the highest level, it's kind of the example I showed you a minute ago, is where we get into the more niche things. Nonlinear studies, linear dynamic and nonlinear dynamic studies. Very easily, this adds composites to anything as well. So if you're running carbon fiber, you want to do fiberglass layup, simply the ability to do composites, even in a linear static, is Simulation Premium. But this is an area where we really want to evaluate, is it the right tool for the job? I'd say in most cases it is. Even if you're doing shaker table stuff, seismic stuff, gasketing applications, living hinges, we find Simulation Premium fits the bill the majority of the time. But every now and then, we find we need some more power, and that's when we'll move towards the connected 3DEXPERIENCE structural roles, which looks like this. There's actually 4 of them. I mentioned 2 before for kind of what is even more powerful in terms of physics capabilities than you have in SOLIDWORKS Sim, but there's 4 here. The first one is called Structural Designer. Now let's say you have 3DEXPERIENCE SOLIDWORKS. You're new to it. That's the cloud-connected version of SOLIDWORKS. It actually doesn't have Simulation Professional and Simulation Premium. So if you want to get into frequency, thermal, or buckling, you would come straight to Structural Designer. And you can move up a little bit from there into Structural Engineer, where we've got modal analysis, modal dynamics, harmonic responses, a few other bells and whistles. You can start doing multi-stepped loading. And then where we get into above and beyond SOLIDWORKS simulation tools starts at Structural Performance Engineer. That's where that nonlinear solver really comes in. Advanced material models for sure. Nonlinear dynamic implicit solving. And if you got to go faster that and do dynamic explicit, Structural Mechanics Engineer at the very highest level. You'll also see the word durability attached. Durability performance or durability mechanics. That durability means it does fatigue analysis, and this is high cycle and low cycle fatigue. Really, everything here, even when you see some overlap with what's capable inside of SOLIDWORKS, it is a bit more powerful. So you might ask, oh, why would I pick up, Structural Engineer, Structural Designer if I already have SOLIDWORKS Simulation Premium? Wouldn't I just want to go to these higher levels? And Well, there's actually a lot more going on under the hood. For me, one of the biggest things is advanced meshing tools. Automatic and manual meshing, local mesh controls. You can do rule-based meshing, so if you have a big assembly, it's way easier to go through and mesh everything in there based on a structure, a templatized rule system you set up. Once you mesh a part, that part can be reused, that mesh can be reused in assemblies. It's actually faster meshing. But bricks and quad elements, continuum shell elements, things that we don't have inside of SOLIDWORKS at every level we have in 3DEXPERIENCE. And advanced solving tools. I mentioned all of this is using the Abacus solver, even when you're running the linear static stuff. You can solve this locally on your machine, or you can solve it in the cloud. It actually comes with an embedded license for a number of cores on Dassault Systems cloud servers, and you can spend some credits to solve up to 144 cores. So solve time, big reason to come here. Materials can hold quite a lot more information, and I really like the automatic contact detection. You know, in SOLIDWORKS, there's some ways to get close to this to say, oh, we've got touching faces, so they should all be welded, or etc. Over here, all of the contact by default is considered that sliding real-world contact, and you don't have to specify it. Though you can get in and specify more advanced friction and slip conditions above what's possible in any area of SOLIDWORKS. But if you just leave it on automatic, it understands we're talking about this real-world sliding contact no matter what the gap is. So this might be an easier way to look at the four tiers here. Structural designer, where you've got linear statics, frequency, and buckling. This comes with 4 cores of embedded compute. So that could be local or the cloud, or you can spend cores to unlock more locally or do more cloud solving. Structural engineer, the next level that comes up, includes thermal and linear dynamics. Also gives you those 4 cores built in. And then at the higher levels, performance engineer or durability performance engineer, if you want to include fatigue, gives you 8 cores of cloud computing. Same with durability and mechanics engineer or structural mechanics engineer. You can get, so I wrote 8 cores before, but it's actually 8 cores of cloud compute there. And you can just see the level of simulation we're talking about. Highly nonlinear buckling of a square tube, highly explicit dynamic events, even with your parts breaking, receiving damage, and stripping apart, the mesh actually separating, which is not something you could, do inside of any level of SOLIDWORKS. So a few examples here. This is literally the stuff that car companies use to virtually crash their things into bollards before they go for the real world. So high strains, complex contact and buckling events, things like riveting operations, even bottle crushes or blow molding, where things can behave a bit like a liquid, but we're still in finite element analysis. So I'd like to give you a little example of what this looks like inside of SOLIDWORKS. And it all starts with just an add-in, a 3DEXPERIENCE add-in. This would be the same add-in you would use if you're going to do cloud data management and save your files up and rev control them in a cloud server. This all comes with it. Here what we've got is a SOLIDWORKS simulation already set up of a 3-point bending test, but it's highly nonlinear, and I want to take it over to 3DEXPERIENCE. Everything that can be matched up, let's say our supports, our fixtures, our loads, materials if they're there, are transferred over into the world of 3DEXPERIENCE, and then we're ready to just kick off this new simulation. Now the interface might look a little different at first because it is a different piece of software, but the areas are pretty similar. What's new is that you can do these advanced things like cloud computing, materials, advanced contact, and of course a huge spread of meshing techniques that is not something we've seen inside of SOLIDWORKS simulation in the past. The interface has kind of a command manager at the bottom, a tree over on the left, and an assistant panel on the right, kind of like the task pane of SOLIDWORKS. So a little bit new interface, but you should feel comfortable in it. And even if you don't, use this assistant panel and just walk through. You'll see green checks on anything that was automatically transferred over from SOLIDWORKS. Anything with a red circle needs a bit more information, and we can get into things like the advanced contact property here. Of course, general contact is what I use for most things. If you've got sliding contact, this can understand the connection between, or interaction between all of your components, so you don't have to manually set these up. Now this is a nonlinear solver, so I am setting up a step size inside of here, a pseudo time curve, if you will, and adding some more advanced material properties. Of course, we have a handful of nonlinear material models inside of Simulation Premium, but it pales in comparison than what can happen over here, where we've got Abacus multiphysics materials. Meshing as well can be done, of course, with tetrahedrals for complicated geometry and automatically mesh just about any shape, or you can switch to things like brick and quad meshing, even continuum shell meshing. For the higher level roles here, structural performance engineer and structural mechanics engineer, you can solve with 8 cores locally or in the cloud, or spend some credits to solve with, as I said, up to 144 cores. So although we're talking about a more complex analysis, it can solve in less time and without using up your computer's resources. So you can actually kick a simulation off, shut your computer down, and leave. Yeah, this is all cloud connected, so you could log in with your phone and see how your simulation's going somewhere else and come back and just open it up and check those results. All right, this solved nicely. You can see there's quite a lot of permanent deformation going on here, something that would be quite tricky to do inside of SOLIDWORKS simulation alone. And I think that's kind of the coolest stuff here, things that are beyond capabilities that we've ever had before. But that can be completely connected to SOLIDWORKS, so we can make a design change, we can iterate, we can optimize. If you're interested in these types of analysis, stuff with actual damage, things that go beyond their actual yield point of the material, these higher level FEAs, or just getting into stuff that is cloud connected and allows you to cloud compute, please let us know. Definitely check out our YouTube channel where we've got other videos on cloud data management and other simulation tools that we can now connect SOLIDWORKS to in a parametric way.